We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Myself, Divyang Patel, working as an assistant professor in Electronics and Communication Engineering Department at SHANKERSINH VAGHELA BAPU Institute of Technology, BAPU Gujarat Knowledge Village Campus, GANDHINAGAR. Today, I am going to conduct the lecture of the subject Digital Electronics and Digital Instrumentation. The subject code for the subject is 3340904. Topic to be covered in the today's lecture is the multiplexer, demultiplexer, encoder, decoder. Let's start the first multiplexer. What is multiplexer? It's a combinational circuit that selects the binary information from one of many input lines and direct to a single output lines. It means it has the many inputs and the single output. The selection of a particular input line is controlled by the set of selection lines. Normally in the multiplexer, total m input lines are there and the n selection lines are there, where m equal to 2 raised to n. Here the m and n both are integers. So now let's see the simple 2 to 1 multiplexer. It has the 2 input and the single output. So the basic block diagram of the 2 to 1 multiplexer, it's 2 inputs I0 and I1. It has the one selection line S0 and the single input, single output Y. Here if the multiplexer having the enable line, then we need to enable the multiplexer before going to do any task. Now the function table for this 2 to 1 multiplexer, it has the single selection lines, so total 2 possible combinations for the single selection line, and it has the single output Y. Whenever the value of the selection line S0 is 0, it gives the output Y as a I0, and whenever the value of the selection line S0 is equal to 1, at that time it gives the output Y as I1. So based on this function table, we can easily write down the logic expression for this 2 to 1 multiplexer. So logic expression for the 2 to 1 multiplexer Y equal to, here from the function table, S0 value is 0 for the output I0. So here the Y equal to S0 dash I0 or S0 I1. So this is the logic expression for the 2 to 1 multiplexer. Now let's see the logic diagram for the 2 to 1 mux. So here 2 to 1 mux, it has the 2 AND gate. First AND gate having the input I0, second AND gate having the input I1. One selection line S0 is provided to the each AND gate. Here for the I0 input, we provided the S0 bar value. So for that NOT gate is required. And for the I1 value, we provide the direct S0 value. So here, after that, we have to combine this 2 output of this 2 AND gate by using the one single OR gate, which gives the single output of the 2 to 1 mux. So here, this is the logic diagram for the 2 to 1 mux with the enable line. Here enable line is high at that time. This logic diagram works as in 2 to 1 mux. Otherwise, it will be disabled. Same way, 4 to 1 multiplexer. It has the 4 number of inputs and the single number of outputs. Due to the 4 input, it has the 2 selection lines, S0 and S1. So this is the basic block diagram. Now let's see the function table for this 4 to 1 mux. It has the 2 select inputs, S0 and S1. Due to 2 inputs, we have the total 4 possible combinations, and that's why here in the function table the 4 possible combinations shown, and for this each 4 possible combinations respective outputs also shown in the function table. For the value 0 0 of the select input as 0 and S1, the output y is equal to I0. For the value 0 1, output is I1. For the value 1 0, output is I2, and for the value 1 1, output is I3. Based on the function table, we can easily write down the logic expression for this 4 to 1 multiplexer. Here, let's start the writing of the logic expressions. For the first row of the function table gives the term S1 dash S0 dash I0, or second row gives the term S1 dash S0 I1. Third row gives the term S1 S0 dash I2, and the fourth row gives the term S1 S0 I3. So this is the logic expression for the 4 to 1 mux. Let's see the logic diagram for the 4 to 1 mux. So here 4 to 1 mux is the 4 AND gate. All the output of the 4 AND gate is ORing with the single OR gate, which gives the final output Y. Here the 4 input is provided. Here the 2 selection line S0 and S1, different values for the all the inputs is provided based on the selection lines S0 and S1 value. So here for the I0 input, S0 bar, S1 bar is provided. For the I1, S1 bar, S0 is provided. For the I2, S1, S0 bar is provided. And for I3, S1, S0 is provided as an input. So this is the logic diagram of the 4 to 1 mux. So now let's see some applications of the multiplexer. So multiplexer can be used as a data selector, data routing. It's also used as a logic function generators. By using that, we can generate the different logic functions. It's also used in operation sequencing, parallel to serial conversion, and the waveform generations. So these are some applications of the multiplexer. Now let's see the demultiplexer. Same way, the opposite operations can be performed by using the demultiplexer. Here the demultiplexer is a device that allows the binary information from one source to be routed onto multiple lines for transmissions over the different destinations. It means in the multiplexer there are a number of inputs and single output, but opposite to the multiplexer, in the demultiplexer, the number of inputs, number of outputs and the single input lines. So here normally in the 1 to m demux, m number of outputs, n control inputs, and the single input D as a data input. Data input D may be transferred to one of the outputs depending upon the control inputs n. So now let's see the simple 1 to 2 demux, so you can easily understand the concept of the demultiplexer. So here now it has the single input D, single selection line as an control input as 0, and the 2 output O0 and O1. So the R function table here for the single select code, single select input, we have only the 2 possible combinations 0 and 1. Whenever the select value is 0, at that time output O0 is activated and it gives as an input data D. Whenever the S0 value is 1, At that time, the output O1 is activated and it gives the value as an input D. So this is the function table. So now for this, the logic diagram for the 1 to 2 demultiplexer, it has the 2 AND gate, 2 output, single input and the single selection line. So this is the logic diagram of the 1 to 2 demux. Now let's see same way the 1 to 4 demux. It has the single input, 2 selection lines or the 2 select input and the 4 output O0, O1, O2 and O3. For that, the function table, due to the 2 selection line, 4 possible combinations are there, and based on the different combinations of the selection line, it gives the output. Whenever both the selection lines are low, at that time output O0 is activated and gives us a D value. Whenever the S1 is 0 and S0 is 1, at that time output O1 is activated and it gives the output as a D. Whenever the S1 is high and S0 is low, at that time output O2 is activated and it gives as a output D. Whenever both are high, at that time output O3 is activated and it gives the output as a D. So this is the function table for the 1 to 2, 1 to 4 demux. Now let's see the internal diagram or the logic diagram of the 1 to 4 demux. So here it has the 4 AND gate with the different combinations of the data input D, selection line S0 and selection line S1. So here let's see the logic diagrams with the different combinations of the input. It has the 4 outputs O0, O1, O2 and O3, and the term related to the each output also written in the screen. So this is the 1 to 4 demultiplexer. Now let's see the decoder. Decoder is a combinational circuit that converts the binary information from n input lines to a maximum of 2 raised to n unique output lines. In other words, a decoder circuit looks at its inputs, determines which binary number is presented there, and activates the specific output which correspond to that number. All other output remains inactive. So let's see some practical examples of the decoder. So in general, decoder with n inputs and m outputs. It's known as the n to m line decoder. Here the m must be less than or equal to 2 raised to n. So total n inputs, m output. For the n inputs I0, I1, I2 up to in minus 1, O0, O1, O2 up to om minus 1, total m outputs. So this is n to m decoder. Let's see the 3 to 8 line decoder. So it has the 3 input, 8 outputs. So the general block diagram for the 3 to 8 decoder is shown in the screen. A, B, C, 3 inputs, and the D0, D1, D2, D3, D4, D5, D6 and D7 are the outputs, 8 outputs. So let's see the function table for this 3 to 8 line decoder. Here the 3 inputs A, B, C and the 8 outputs D0 to D7. For the 3 input combinations, 3 input variables, there are 8 possible combinations. Here for the 8 possible combinations, based on the value of the each combinations, the separate output is activated. Here in the first case, A, B, C all are low. At that time D0 output is activated. Whenever 001, it means the 1 decimal of 001 is 1. At that time D1 is activated. Whenever the input combination is 010, its decimal value is 2. At that time D2 is activated. Same way, whenever all the 3 inputs are high, it gives the D7 as an activated output. So this is the 3 to 8 line decoder function table. Based on the function table, we can easily draw the logic diagram of the 3 to 8 line decoder. So let's see the 3 to 8 line decoder. Here the total 8 AND gates are required for the each output one single AND gates are required. And here the 3 inputs ABC, the different combinations of the input is provided to the each AND gate, and based on the different input combinations it gives the output D0 to D7, and the term related to the output is also written respectively from D0 to D7. So this is the logic diagram of the 3 to 8 line decoder. Now the last topic, the encoder. Encoder is a digital circuit that performs the inverse operations to the decoder. Here encoder has 2n input lines and m output lines. 2n input lines and n output lines. The output lines generated the binary code correspond to the input values. So let's see the some 4 to 2 encoder. So we can easily understand the concept of the encoder. Here the M is the input, N is the output. So 4 inputs and the 2 outputs. So it's also known as the 4 to 2 encoder. So here the 4 inputs and the 2 outputs. D0 to D3 4 inputs are there. Here the A and B 2 outputs are there. So for that the function tables shows the 4 input D0, D1, D2 and D3 and 2 outputs A and B. Based on the value of the input, the output gives the corresponding value. So whenever the D0 input is high, at that time the output A and B value is 0, 0. It indicates the equivalent decimal as a 0. Whenever the D1 is activated, it indicates the equivalent decimal of the output is 1. Whenever the D2 is activated, at that time output of AB is 1, 0. And whenever D3 is activated, at that time the output A and B is respectively high, 1 and 1. It means its the decimal equivalent is D3. So based on the activated input, it gives the corresponding value as an output. So based on the function table, we can easily draw the logic diagram for the 4 to 2 encoder. So it requires the 2 OR gate. Here the value for the logic expression for the A output is D2 and D3. This is based on the function table. Here if you see the function table of the 4 to 2 encoder, in that in the output A only 2 times 1s occur. Once at that time first one occur whenever the D2 is activated and the second one occur whenever the D3 is activated. So that we can easily say that the function or the logic expression for the A is D2 or D3. D2 or D3. Same way logic expression for the B output can be easily find out from the function table. Here in that also the 2 times 1s occur in the column of B. So first one occur whenever the D1 is activated and the second one occur whenever the D3 is activated. So the logic expression for the B is D1 or D3. So based on the logic expression, we can easily draw the logic diagram for the 4 to 2 encoder. So let's see the logic diagram of the 4 to 2 encoder. So here now for the A, D2, connect the D2 and D3 as an input, which gives the A as output, and for the B, connect the D1 and the D3 as an input, which gives the B as an output. So this is the logic diagram for the 4 to 2 encoder. Now let's see the same way octal to binary encoder. This is the well-known encoder, octal to binary. It has the 8 inputs and the 3 outputs. So the 8 input D0, D1, D2, D3, D4, D5, D6 and D7, and the 3 outputs C, B and A. So for that, the function table, it shows the first D0 is activated. At that time, the corresponding value of the output is 0, 0, 0. D1 is activated. At that time, corresponding value of the output is 0, 0, 1. Same way from D2 to D7. So here for the last D7 activated, at that time, the corresponding value of the output is 1, 1, 1. So based on this function table, we can easily find out the logic expression. So let's find out the logic expression from the function table, and then we will draw the logic diagram. So now derive the output equations. So here in that table, in the column of the A output, total 4 times 1s occur here. So based on these 4 ones, we can easily write down the corresponding activated inputs. So for the A equal to D4 or D5 or D6 or D7. So this is the logic expression for the A. Same way, we can easily find out the logic expression for the B. In the B column of the B, 4 times 1s occur. So write down the corresponding value, input values for these 4 ones. So here the B equal to the D2 plus D3, D6 or D7. So this is the logic expression for the B. Same way, we can easily write down the logic expression for the C. In that also the 4 times 1 occurs. So first one occurs whenever D1 is activated, second time one occurs whenever D3 is activated, third time one occurs whenever D5 is activated, and the last one occurs whenever the D7 is activated. So that the logic expression for the C is equal to D1 plus D3 or D5 or D7. So this is the octal to binary encoder and the logic expression for the A, B, C outputs. Now let's draw the logic diagram for the octal to binary encoder based on their output equations. So it requires the 3 OR gates, for first one for the C, second one for the B, and third one for the A. Now based on the output logic expression, we can connect the input D0 to D7. So for the A, the logic expression for the A is D4 or D5 or D6 or D7. So we connect the all 4 inputs, which gives the output A. For the logic expression B, here it's a D2 or D3 or D6 or D7. So we connect all the 4 inputs, which gives the output B. And the last but not least, the C output is based on the input combinations D1, D3, D5 and D7, which gives the output C. This is the logic diagram for the octal to binary encoder. So this is all about the multiplexer, demultiplexer, encoder and decoder. So that's it for this. Thank you.